equations. So a system of equations is two or more, but they do have to be linear equations, has to be straight lines. So two or more linear equations. Two or more. So you could have obviously like way more than two, but it has to be a minimum of two in order to be a system.
Same class project is basically a system of equations.
It was a system of equations. Yes, it was, because it was more than two groupings of linear equations. Exactly. Yeah. Okay, now a solution to a system of equation just means the point where your lines are going to intersect one another. And what does intersect mean? It's where they cross each other. So when we look for a solution of a system of equations, it does have to be a point. Okay, a point on the graph. So it's an ordered pair. An ordered pair. So it has to be, right, an XY coordinate. Okay, so it's going to be one point, and it's where your lines intersect. So where lines intersect. An ordered pair where my lines intersect. So there are three different types of solutions that you can have. Because when you think about it, and you think about lines on a graph, you've got some different choices. Either they will cross each other and intersect at one point. They might never cross each other. What is it called if they never cross each other? Parallel, right? Or they might be right on top of each other, like one line directly on top of the other one. So it's the same equation for both. And those are the only three different types of solutions that you can have. So the first type of solution looks like this. It's where my two lines intersect or touch, and they should only intersect at one point. So a solution that looks like this, your point, I'm going to do this in a different color here. The point where they touch each other, where they cross, is your solution. So in this picture here, this point where they intersect, that's your solution right there. And that would be an XY coordinate, whatever it is. So this is when you have one solution. Yes, Laura?
Wait, so basically you're graphing the lines and then you're trying to see where the dot is?
Correct. So that's your answer, yes. So where the two lines intersect one another is going to be where your answer is. So that would be one solution. There's one number, that's your solution. It's the one coordinate point. If you have parallel lines, right, these are parallel. Parallel lines. What do you know about parallel lines? They never intersect or never touch. So what do you think how many solutions can you have if they never touch? None. There is no solution to a problem that is parallel lines because they're never going to intersect each other. So if you have two parallel lines that have the same slope, you have no solution. There's no answer because they never touch. And instead of writing out no solution every time, there's a little symbol for it just so that we don't have to write the words out. And it essentially looks like, yeah, it's a zero with a line straight through it. That means no solution. So we don't have to write that word every single time. And then the last type of solution is when you have essentially a line that's right on top of another line. So you've got an equation of one line. The other line is right on top of it. That creates something called infinite solutions because they're touching the entire way. So all of the points would be considered solutions. So if it's the same line, it's considered infinite solutions. Mm-hmm. And just like with the no solution, we have a symbol for it. And the infinite solution, does anybody know what that symbol looks like? It's the infinity sign, which is essentially, it's an 8 that's been like pushed over to the side. It's like a lopsided 8. Looks like this. Infinite solutions. If that's too hard, you can just make two little circles next to each other. It's close enough. So one solution is where the points cross each other, where they intersect. No solution is when you have parallel lines because they never touch. And then infinite solutions is you have the same equation of the same line more than once because they're touching multiple places. So the first way we're going to solve systems of equations, there's 3 different ways to solve. Today we're going to learn just one type, which is graphing, because you guys are pros at graphing at this point, so this one should be easy peasy for us. So to solve by graphing, we want to make sure that our equations are in slope-intercept form. Okay, so you want to make sure that they're in y equals mx plus b form, because that's going to make your life easier when you go to graph it. What does that m stand for again? The slope. And what does that b stand for? Y-intercept. Good. Okay. So I'll help you with like a couple of them, and then I'll let you try a few on your own. So for number 1, you want to make sure that they are in y equals mx plus b form. Are both of those equations in the right form? Heck yes, they are. So I've got no work to do there. So let's start with the first one. And I'm going to do mine in like 2 different colors so you can see the difference between the 2. Okay, first one is y equals x minus 8. Now, where should I start? Like, where should my starting point be for that graph?
Y equals x minus 8?
Yes, but where I go to graph it,
Negative
8, right? It's a minus 8. And you want to go on the y-axis. So you're going to go down 8. So there's your first point. So everybody go down 8 and put a point there. 4, 5, 6, 7, 8. Bless you. All right, there's negative 8. Now, what is my slope in this problem? What's my rise and my run? 1 over 1. Which way does that take me then? Up 1?
To the left 1. I mean, to the right, my bad.
To the right 1. Up 1, so 1 over 1 means you go up 1 to the right 1. And yes, you do have to do every single point because we're looking for a specific point. So up 1 over 1 and keep going, and then use your ruler. Essentially should create a really nice kind of like diagonal line. And if I wanted to go backwards, what would I do?
So, the opposite way.
Which is which way? To the left 1 and down 1. Left 1, down 1. Or down, left, whatever. Okay, and then use your ruler. Make a line. And yes, to solve by graphing, we do want to make sure our graphs are really clean and really nice, because if we don't have a good graph, we're not going to be able to solve. Okay, let's try the second one. Second equation. Okay, my second equation is y equals negative 2x plus 1. Where should I start my graph? 1. So it's positive 1, so you're going to go up 1. Okay, what is my slope for this problem? Negative 2 over 1. So which way does that take me? Down 2 to the right 1. Perfect. And what should happen, they better intersect. And since they've already intersected like down below, I'm not going to worry about doing my ones up to the up above over here. So your graph should look something like this. You got 2 lines and they are intersecting. Okay, so does this one have 1 solution, no solutions, or infinite solutions? This has 1 solution.
Do we have to write that on the side?
Yes. You got 1 solution. What point is the solution? So now I want to know, what are the coordinates of that point right there? Remember, x goes first, so it's right or left first, and then up or down. So how many are you moving to the right or to the left? What? Hold on. If you're starting at 0, 0s right in the center, are you going to the right or to the left to get to this point? To the right. How many are you going to the right? 3 to the right. And then how many are you going down?
5.
Down 5. So it is positive 3 -5. That is your solution to this system of equations.
You doing number 2 with us?
I'm not going to do number 2 with you. That's an easy one. Because it's easy. Don't you want me to do the hard ones?
Oh yeah, never mind.
Right? Like, why would I do an easy one with you when I know you can do the easy ones? Why don't I do the hard ones with you, right? Right. Okay. So let's pause there for a sec. Questions there so far? No single question? Do we feel like graphing pros?
No. Well, yeah.
Almost at a graphing pro?
Well, no,
If you had to rate your graphing skills on a scale of 1 to 5, show me with your fingers, what would you be at? 1 to 5. With your fingers.
4.
Everybody. 1 to 5. What's your graphing skills?
4.5.
Okay. Okay. All right, flip it over. Yeah, let's do a hard one together. I'm going to do 3.
Oh, no, not really. That's not hard.
You know what we should do?
Oh, we have to
Let's do
solve them,
4.
don't we?
Let's do 4. 4 is a good one.
We have to solve them.
You do want to solve them. Okay, so let's start with number 4. Are these two equations in slope-intercept form? No. Although one of them is. Isn't one of them already in a good form for me?
Mm-hmm.
Yeah, which one? The bottom one, so why don't we just graph that one and get it out of the way? What do you think? Let's graph it, get it out of the way.
Up 4.
Now hold on, you just said the second one.
No, you said the second.
No, the first one's not in the right form. You want y equals mx plus b. That first one is not in that same form.
Oh, hold on.
The second one is. So let's graph the second one. Hey, you don't have to go in order. You're allowed to go out of order. You know all that? Where should I start this graph? Up 2. Good. So go to +2 and plot your point. Now, what is my slope?
That's negative.
Down 1 to the right 2.
Down 1 to the right 2. Yeah, but so here's the thing. If you went down 1 and left, that would be a negative over a negative. And what happens with two negatives?
Negative,
Right, but so listen to me. If you go down 1 to the left, that's a negative divided by a negative. And what happens with a negative divided by a negative? It really becomes a positive graph. So when you've got a negative sign in front, that's saying the whole thing's negative. But really, it just goes with the direction of your graph. So really, it only goes with one of the numbers. Okay?
Just the top one?
Yes, the top one. So negative 1/2. Yeah, so we just don't write it that way. So negative 1/2 means, essentially, it's -1 over 2. So -1 means you would go down 1 and then to the right 2. Down 1 to the right 2. Okay, so graph that. Down 1, right 2. And then just keep going.
I think you said down 1.
I think go down 1.
Oh, no.
You got me nervous there. Okay. And then if I want to reverse it, I go up 1, left 2. Up 1, left 2. So it should look something like this. It's got my negative slope, right? I'm going down a hill. Going down a hill, so we're good there. Okay, there's one of the equations. I still got to do the other equation. Now, this equation here is not written in the correct form. I have to rewrite that equation to be in the form y equals mx plus b. So we have to do a little bit of algebra.
So, just do the
No, so here's the issue. Intercept method, the shortcut way would be great, but what's going to happen is there's going to be some funky numbers soon, and they're not always going to work out that way. Additionally, that only gives you 2 of the points, and it's not accurate enough when I go to graph, unfortunately. So we are going to rewrite this. But that was a good question. Okay, so I want to get the y by itself, so what should I do first? Matt? Good. Subtract the x from both sides. Walk me through it, Matt. Keep going. Plus 4. Good. And then what's my last step? Divide everything by 2. Good. So on the left, my 2's will cancel. You're left with y equals. Now, you've got a negative sign in front of that x. What number can I put there if there's no number there?
1.
A negative 1. So my slope is a negative 1 over 2x. And then what is 4 divided by 2? 2, a positive 2. There's my second equation. Now, hold on a second. What do you notice?
It's the same thing.
It's the same thing. It's the exact same equation as this one. That means if I went to go graph this one, it would overlap, right? The pink one would go right on top of it. It would overlap. So, do you have one solution, no solutions, or many solutions? You've got many solutions. Yeah. What's your answer here? You've infinite solutions because this line's going to go on forever to the left and it's going to go on forever to the right. So your final answer for this problem is infinite solutions or infinity solutions or many solutions, however you want to write it. I'm going to write it like this. Infinity solutions. Infinite solutions. Mm-hmm. All right, questions so far up to there. What questions can I answer? None? I can't, yes? Which part?
Well, because we would divide, as we do minus 3x, we divide regular 3x. I don't know how to simplify it.
On number 3? The first equation? Is that what you're saying? Sorry, I got lost. I didn't know what question you said, so I was trying to find it. Okay, yeah, we can rewrite this one. Okay, so let's go to number 3. We can rewrite that. The first equation you said, right? Okay, so both of these equations for number 3 are definitely in the wrong form. We want to get them into y equals mx plus b form. Okay, so I'm going to start with this top one. I'm going to rewrite it. I'm going to do it up above just because I have more space. I'm going to do this one up here. Negative 3x plus y equals 8. Okay, so then Matt, tell me what you did first.
You have to subtract, the negative 3x would be negative a positive 3x.
Good, so it's really adding the 3x to both sides. Okay, then what?
Well, that's fine.
So now on the left side of the line, what's left over? What's the only thing there? It's just the y. On the right side, which one of those goes first? The x. So I'm going to write 3x. And then what am I going to write? Plus 8. And there's your equation.
Oh, that's it?
Yeah, that's it.
Okay, very simple.
Yeah, it seems simple, right? It was like, this is too good to be true. Okay, so you'll graph that one. I'm not going to graph that one with you. Why don't I just help you rewrite the second one too, and then you guys can graph those. And then I do want to do one more with you. So let's let's write the equation of the second one now. What should I do first to get the y by itself for the second equation?
Add the x.
Add the x.
On both sides.
Good. What do you get for your equation?
Y equals negative x subtract 2.
Oh, careful.
Oh, no, okay. Plus x, well, positive x.
Positive x
Why is the problem there?
minus 2, because it was negative over here. So to undo the negative, I'm adding to both sides. So there is your second equation you're going to graph. I think you guys can graph those too, yeah? Why don't we just finish this one then? Graph those two. So you take a second, you graph them, I'll graph them too, and we'll see if we get the same picture. So remember, start where your intercept is and then follow the slopes.
The first equation,
The pink one?
it's gonna go off the graph.
Yeah, it might. That's okay if it goes off a little bit. Which means you'll have to reverse that graph. Yeah, and that's fine. Eight. Correct. There's my pink graph so far. If you want to check yours, the first graph, you have to reverse it. And my second graph, 1, 2. My slope is 1/1.
This one's one solution.
Huh?
This one's one solution.
This one, yes, already looks like is going to be a 1 solution.
They cross over.
Yep, they cross over at 1 point. So yeah, now that's the question. What point? Wait, what?
But why cross at 1 point if it's 3x? No, that's not the one.
So here's what I had to do. That pink one, the 3x plus 8, that means you go up 3 to the right 1, but that's going to go off the graph over here. So I actually have to reverse it. I have to go down 3 to the left 1, down 3 to the left 1, because that one goes a little bit off the graph. My blue one here starts at -2, and then my slope is 1/1, so you go up 1 to the right 1, up 1 to the right 1, and then reverse it, down 1 to the left 1, down 1 to the left 1. So your graph crosses at 1 point. So how many solutions do you have?
One.
You've got 1 solution. The question is, what point is that solution?
-5,
-5, -7. Perfect. So look, you can solve a system of equations just by graphing it. And your solution is those points where they cross one another. Let's do one more together. Yeah?
Yeah.
Okay, let's do one more, and then I will let you try the last few that are left over. Let's do number
5.
No, I want to do 6.
Oh, y is already on us.
No, it's not.
It's not? The first one?
Are you looking at number 6?
Yeah.
Okay, number 6. Oh, you're saying the equation's written correctly.
Yeah.
Yes. So good. Yeah. Equation's written correctly for the first one. I'm going to do this one in pink. All right, so you should be able to graph this one. Where do I start it?
5.
+5, so go up 5. And then what's the slope for this problem? 1/1, so which direction do I have to go? Whoa, 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 whoa. Positive, positive. Up 1. Which way is positive?
To the right. I
To the right. I don't either. Bless you. Up 1 to the right 1. It was a very dainty sneeze. Like very, very cute and small. So +5 is where you're starting, then you're going up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. Love when the equations are already written correctly for you. That makes life way easy. Yeah.
I have a question.
Why is it 1 1?
So there's no number in front of the x,
Oh, okay.
and that's what your slope is, and it's assumed if there's no number there, you can put a 1 there. Yep, good question. So anytime there's no number, it'll always be 1 over 1. Good question. All right, second one is not written in the right form, which means we have to rewrite that one in the right form. You gotta get the y by itself. So what should I do first? Move the x over by doing what?
Minus it.
By minus. Yep, subtract it from both sides. Minus x minus x. So you've got negative y equals what? Negative x plus 2. Now you're not done. You got to divide the negative sign, yes, on all of them. So if you want to put a little 1 there, you're welcome to. Put a little 1 there. Divide everything by negative 1. Got to get rid of that negative sign. So my negatives on the left right here, they cancel out. These go away. You get y equals what?
X.
Positive x. If you want to put a 1 in front of it, put a 1 in front of it. And then what is 2 divided by negative 1? Negative 2. So now when I go to graph this, where do I start? Down 2. And then what's my slope? Up 1.
To the right.
To the right 1. Yeah, up 1 to the right. Up 1 to the right. Oh my gosh. These are parallel. Up 1 over 1, up 1 over 1. Okay, you get the gist. I'm not going to keep on going. They are parallel lines. Here's a really easy way to tell that they're parallel. Ready? Look at the slopes. If the slopes are the same, exactly the same, they are parallel. What is the slope for the first problem? Whoa, the first one, the pink one.
Oh, 2. No, wait, what?
What's the slope in this first problem in number 6? It's a 1 over 1. What's a slope? You said negative. What's a slope in the second one? 1 over 1. They're exactly the same. That means they are parallel lines. So what is your answer? How many solutions are there?
0.
No solutions. No solutions. Good. No solution. If you want to write the words no solutions, that is fine.
It would be easy to solve that without a graph.
I know. So that's why I'm showing you. This is just one way to solve the problems. I'm going to show you different ways this week. I'm going to show you 2 different ways. But yes, graphing is one option. If you're a graphing kind of person, if you like to graph, this is the way for you. But if you don't like to graph, maybe on Wednesday, you're going to like the other method I show you on Wednesday. All right, questions so far? Feel okay? No? Do you want a test?
Nope.
Okay. Yeah.
Neither Thursday, Friday, or Monday.
That seems like,
Is there any work?
I feel like, feels like a lie, but okay.
It is a lot.
No, I said a lie. Where are you going?
Feels like a lot.
Yeah. Oh my gosh, you did tell me that. Okay. Do you want me to do another one with you, or are you ready to do the last 3?
One more. You offered it. Exactly. Sure you knew what we were gonna say.
Do number 7.
Oh yeah, number 7.
No.
Why?
No, I'm not doing 7. I'll do 5 or 8. Which one do you want me to do?
8.
8. Fine. We'll do 8 together, and then you got to do the last 2 on your own. All right, number 8.
We have 3 to do on our own. We still have number 2.
Okay, that one too. Number 8. Now, take a look at the first equation. First equation is x minus 2. How do I graph x minus 2?
Are you going to x and wait? Do you want to find the 0 point and then go over to the x and then do 2?
Yeah. Yeah. So go to negative 2 on the x-axis. X is left and right. So go to negative 2. That means to the left 2. And I need to make a line that intersects that line right there. So which way does it have to go? Has to go straight up and down. Yep. There's your first line. I'm gonna make you a little cheat at the bottom of your paper here. We'll say x equals 1 is, or whatever, is a vertical graph. If I have y equals 1, that is a horizontal graph. Okay, that's just a way to give you a little cheat there so you don't forget. Okay, look at that. You already got one graph,
So like
one line graph.
Number 5.
Yep. You
Okay.
better have a horizontal line there. Hey, already, how many solutions do you think this problem is going to have?
Infinity.
It could be infinity, or,
1.
well, I guess there's no real way to know, right? Because never mind. Never mind. Pretend I didn't even ask that question. That was a bad question. Okay, let's look at the second equation. Is that written in the right form? Heck no, it's time to rewrite it. So you're going to take a second. You're going to rewrite it without me. What? Let's see if we get the same thing. Rewrite it. Yep. Nope. Try to rewrite it, get that y by itself.
Can this be a fraction?
Of course it could be a fraction.
Don't you divide, right?
Now you divide by, bless you,
Negative 2.
-2. So this is always where everyone's making their mistakes. It's like this thought. It's the signs that kill us. What's your final equation?
Y equals negative 3/2 and negative 9. No, it's 3/2.
So it's a negative and a negative.
Oh yeah. That's what I got.
It's a
Y equals
positive
-3.
3/2.
Plus 9.
Yes. So look, this is straight up on all the stuff that you guys are doing. You're all getting the right equations, but 99% of us are making mistakes on the signs. And that puts everything off. Okay. So what does this graph look like? Where do I start? Positive 9. And then what's my slope?
Go up 3, go to the right 2.
Up 3 to the right 2, but already I see that that's going to go off the graph, so I'm going to reverse it, and I'm going to go down 3 to the left 2. Ooh, and look at that. The first point that I did, yep. How nice. Yes, this is one solution. But the question is, what is that solution?
Is this a grade in the back?
Down 3. Negative 3 over negative 2. On it. What?
What?
-2/6.
Laura got negative 2/6. Do we agree or disagree with her?
I don't know.
Carly agrees. So if you're at 0, 0 right here, you're going left 2, up 6.
Oh, yeah.
6 and 2.
Yep, but so you went left first, right? -2 to the left. And then positive 6 is up 6. Woo! Okay. All right, my friends. I want you to do 5 and 7 for homework, and I'm going to grade those tomorrow in class.
Did she just say
In class. Yeah, can you not do 2 problems?
oh,
Just 5 and 7.
I got 3.
Just 5 and 7's fine. Don't worry about the front one.
Don't do 2.
If you want to, go for it. But I know, I said homework.
Oh, wait.
Yep, 5 and 7.
I'll do number 2 anyway.
All right, good job, guys. we will pick up with that tomorrow. Again, 5-7, I'm gonna check them tomorrow.
There's one lunch today, right?
Yeah.
No, not today.
Yeah,
Oh wait, today's one lunch, that's what you said, yes. You're correct.
I'm so sad. Literally right after that announcement, there was
I know.
I don't know.
Yep.
That's not fair.
Yep. Just a few people ruin it for all of us.
Right. Whatever. Okay, I'll still go back to that.